This is part 4 of section 1.3. So we're going to be finding the domain and range of a function. If the domain of a function that is defined by equation is not specified, so if they don't specifically tell us, hey, we only want x between 1 and 3, then we all agree that the domain of the function is the largest set of real numbers that results in real numbers as outputs. Another way of thinking about it is that the domain is the set of all legal x values. At this point in the course, we have two things that can go wrong with x. We have to make sure that no value that we plug in would ever require us to divide by 0, because that's not going to be allowed. And we also have to make sure that no number that we plug in would require that we take the square root or any even root of a negative number. Those are the only two things we have to worry about so far. As we go along in the course, as we get to exponentials and logarithms and trig identities, misspoke there, we're going to have more things that we have to worry about. But for right now, those are the only two things we have to be aware of. Okay? Now, a number y is said to be in the range if you take it and you set it equal to that number and it has at least one solution. So basically, if you can find an x value that's going to give you a particular y value, then that y value is in the range. All right, so let's find the domain of each of these functions. When we found the domain of those first problems on the first page of these notes, we had a finite list of x values. It was just finite. I could possibly list them all. But here, when we have just a general relation, there's infinite possibilities. I could plug in 0, 0.1, 0.001, 0.0001. Okay, so we can't possibly list them all. So we're likely going to be asked to provide our domain in either set builder notation or interval notation. And I'm going to be writing both of those here. And which way you're asked to give your domain sort of depends on what use you're going to be putting these to, okay? So if I look at this function, h of x is equal to x minus 3 over x squared minus 4. There are two things we have to worry about: dividing by 0 and taking an even root of a negative number. There are no roots in here anywhere, so I don't have to worry about that. The only thing I have to worry about is plugging in a value here that when I square it and subtract 4, if it gives me 0, then I'm going to end up needing to divide by 0, and that's a problem. So what do? We take the denominator, whatever it is, and we set it equal to 0, because that's the one thing we cannot have happen. So we need to figure out where that happens. And then whatever our answers are here, those are the values we have to pluck out of the domain because they're not going to be legal. Everything else will be. Now this is a fairly simple equation to solve. It factors easily because it's a difference of squares. Or you could just move the 4 over, get x squared equal to 4. Use the square root property to take the square root of both sides, remembering to put in the plus or minus. And you get x equals plus or minus 2. So what I've just discovered is that I can plug in any value for x except for either positive 2 or negative 2, and it's going to be perfectly fine. So my domain, written in set builder notation, this is the set of all x values such that, okay, this is the beginning of set builder notation. Set of all x values such that, and then over here we put our restrictions. X cannot equal plus or minus 2. This says x can be anything as long as x is not plus or minus 2. That's set builder notation. Interval notation, we have to describe using the parentheses and brackets thing and unions, everything it can possibly be. So, you could probably do this without a number line at this point in your mathematical careers, but basically if you think about it on a number line, I need to get rid of these two values. So I describe this region, and this region. Here, that will be negative infinity up to -2. And since -2 cannot be one of my solutions, I use parentheses. Infinities always get parentheses. Union, -2 to +2, also parentheses because those two values cannot be included. Union 2 to infinity. These say the same thing. This is set builder notation. This is interval notation. Okay. The union signs will pop up in the toolbar below where you're entering your solutions. Okay, so let's find the domain of this. In this case, we do have a denominator, which means we have to be worried about our denominator equaling 0. And we also have a root, and it's an even root. Remember, square root has an understood 2 right there, so it is an even root. And we cannot take an even root of a negative number. So what I'm going to do is I'm going to focus on what's inside. Okay. I cannot take an even root of a negative number, so this needs to be greater than 0. Technically, if it were just the square root, it could be greater than or equal to 0, because we can take the square root of 0. Okay? But if it's equal to 0, the square root of 0 is 0, and I would need to be dividing by 0, so that's a problem. If it were just the root, I could have an equal to on it. But since the root is in the denominator, I cannot. So now just solve this by subtracting 2 from both sides. You get x is greater than -2. So your domain in set builder notation would look like this. The set of all x such that x is greater than -2. Okay. In interval notation, this would be from -2 to infinity. Parentheses here because this does not have an equal to on it. Infinities always get parentheses.